Hello. So today's class is going to be about angles. And in order for us to talk about angles, we're going to go back to what you talked about and discussed with your groups in class today, what an angle is. So we came up with some kind of a more formal definition. And an angle is a figure, that's what you guys told me, a figure formed by two rays with the same end point. That's the kind of the definition you came up with. But there were some other things and attributes we talked about. I loved that many of you said it was like a rotation from one ray to another. And I think that that's true because an angle is not a segment, it is not a line, it actually is the rotation from one ray to another. The angle formed is that little rotation there where I put an arrow. All right, well, how do we name angles? Angles are named either with 3 letters, 1 letter, or a number. So if I want to name this angle, one way I could write it would be angle. That's the symbol for angle. It's like a sideways V with like an arc through it. BAC. Okay. I also could name this angle CAB. You may notice the most important part if I use 3 letters is the vertex. It has to be in the middle. This part is called the vertex of the angle. And that letter has to be in the middle if I use 3 letters. If I use 1 letter, I want to use the vertex, so it would be angle A. And sometimes in diagrams they'll put a number in that little arc right there, and then we could call this angle 1. Now, the one that's really important is this one, angle A. We have to be really careful about using angle A. Because what happens if I give you multiple angles in the same figure? And I'm going to do something like this. B, A, C, and D. Well, if I say angle A, I could be talking about this angle, or I could be talking about this angle. So when there's multiple angles in the same picture, you do not want to use the 1 letter. What you'd want to do instead is just figure out which angle you're talking about, and those other 2 letters then become important. If I'm talking about this angle right here, that means these are the 2 rays, right? So I would call this angle BAD. If I'm talking about this angle, then these are the 2 rays, and I would call that angle CAD. CAD. All right, how do we measure an angle? So when we want to write the measure of an angle, so if I give you angle A, that's not the measure of an angle. If I want to indicate the measure of an angle, we would write a little m with the angle symbol A, and that means the measure of angle A. The measure of angle A. Angles are always measured in degrees, okay, in geometry. Angles will always be measured in degrees. All right. Some more things. There are things called congruent angles. There's that word congruent again. I told you we're going to use it all year. Congruent is another name for equals. So angles that have the same measure are congruent angles. Angles that have the same measure are congruent angles. So in this case, we look at it. Angle BAC, you can see the vertex is A. DEF, the vertex is E. They both have a measure of 30 degrees. Because they are 30 degrees, that makes them congruent angles. Okay? Another thing that we can use with angles, another term, is adjacent angles. Adjacent angles share a common side and vertex, but have no interior points in common. Okay. So interior points are angles inside, like here. Anything inside the angle, anywhere up here. These are all interior points, okay? All right, so they share a common side. So here's a common side, okay, to this angle and this angle. They share the same vertex. They both have W as their vertex, and they have no interior points inside. So this angle and this angle are adjacent angles. So angle, sorry, let me go back. Angle XWY is adjacent to angle YWZ. Think of the adjacent angle. It's just like the adjacent room. The room next to us, they share a wall, okay? But they can't have anything else in common besides that common side. All right. Interior and exterior of angle, like I said, interior is everything inside the angle. So anything here, that's the interior. And anything out here, not inside the angle, would be in the exterior of an angle. So outside the angle. All right, so let's just quickly talk about naming an angle versus the measure of an angle. Naming an angle versus finding the measure of an angle. Okay, when I'm doing naming an angle, okay, when I'm naming an angle, I just am going to say angle ABC. If I want you to find its measure, that means I want you to find it in degrees. Then I would say find the measure of angle ABC. And then I know that my answer is going to be something in degrees. So like 30 degrees, 31 degrees, 120 degrees, okay? All right, so now we're going to put all this together. We have another postulate, okay? So let me remind you that a postulate is something that you accept without proof. So I do not have to prove this to you, but the angle addition postulate is very similar to the segment addition postulate. And you may remember that I said with the segment addition postulate, the sum of the parts equals the whole. The sum of the parts equals the whole. The angle addition postulate says that if P is in the interior of angle RST, which it is, then the measure of angle RSP plus the measure of angle PST is equal to the measure of angle RST. So this angle plus this angle equals the whole angle. All right, so how can we use this angle addition when the sum of the parts equals the whole? All right, let's look at this first example. It says find the measure of the following angles. It wants us to find the measure of QRS. So QRS, let me change to red. QRS is this angle. It's that entire angle. Well, I know that this part of the angle is 19 degrees. This part is 23 degrees. So if I want to find the whole angle, I just add them. 19 plus 23 gives me 42. Okay, 42 degrees. All right, is that right? Yeah, 42 degrees. So that's the angle addition postulate. Let's try another one. All right, in this case, it gave me that WXZ, so the whole angle, WX all the way to Z means this angle. Okay, that angle is 48. YXZ, so this angle right here, let me switch to blue here, is 31. How can I find that how can I find WX? So this is what I want to find right here. So I can do 48. Let me just make sure I did that right. WXZ was 48, and I'm trying, okay. So I would do 48 minus 31, and I would get 17. So WXY would be 17 degrees. So that's another way to use the angle addition postulate. That's with numbers, mathematical thinking with numbers. What about when I have algebra? I have variables thrown in the mix. All right, so it says if the measure of angle ABC, all right, so ABC means start at A, go to that vertex of B in the middle, all the way to C. There's my angle right here. ABC is a measure of 88. Well, they told me that this angle is 2x and this angle is x minus 2. Well, that tells me that I can add those two angles together to equal the whole angle. The sum of the two parts equals the whole. All right, so the sum of the parts. So here's the sum of the parts equals the whole. The whole is 88, okay? The first part is 2x. The second part is x minus 2. Now I add them together and I combine the like terms. These are like terms, the x and the 2x. So I get 3x minus 2 equals 88. Then I use algebra, so I balance the equation by adding 2 to both sides. I get 3x equals 90. In this case, 3 is being multiplied to x, so I divide it to both sides, which gives me x equals 30. I go back and look at the question. The question says solve for x. I did solve for x. I found my x, so I box my answer so I can provide clear mathematical thinking. All right, so that's how you use the angle addition postulate. A few more things we need to cover today. We can classify angles by their measure, okay, by their measure. So an angle that measures greater than 0 and less than 90. So between 0 and 90, if an angle is between 0 and 90 degrees, we call that an acute angle. Acute angle is something like that. A small acute angle less than 90 degrees. An angle that actually measures 90 degrees, meaning it is 90 degrees, it equals 90 degrees, is called a right angle. A right angle looks like this. 2 rays. Now I know it's going to be a right angle because I'm going to use a little box to indicate that. A right angle, if I put that little box, I can tell you it is a right angle, which means its measure is 90 degrees. All right. An angle that measures greater than 90 but less than 180, that's called something like this. Greater than 90 and less than 180 is called an obtuse angle. So a big fat angle, okay, an obtuse angle. And then the last one, the hardest one for us to sometimes see, but the most important, is a straight angle. A straight angle also creates a straight line. It actually creates that's the angle, so it creates kind of like that horizon we talked about when we talked about horizontal lines or vertical lines, and that would be a straight angle. Okay. All right, so sometimes I might have to classify an angle. All right, we're going to go back now to congruence. What does it mean if two figures are congruent? It means that they are the same size and the same shape. In order for things to be congruent, they have to be the same shape, okay? That means that they're going to have equal area, they're going to have equal perimeter, okay? All right, the last thing I want to talk about is bisecting. Bisecting an angle. In the last section, we talked about bisecting a segment, and we broke down the word bisect. The word bisect means, bi means two, sect means section something off. So if I'm bisecting an angle, it's cutting an angle into two congruent parts, okay? So it's a ray that divides an angle into two congruent angles. Two congruent angles, okay? So in this case, we would say that AD is an angle bisector of angle BAC. Okay? That makes this angle congruent to this angle. Now look, I used those hash marks. So you got to be really careful. Those little hash marks we put in the arc of the angle, and that means this angle here is equal to this angle. So if a ray is an angle bisector, then it cuts the angle into two equal or congruent angles. And if a ray cuts an angle into two congruent parts, two congruent angles, well then it is the angle bisector. All right, so let's just do another example of that. I might do two of them, okay? So first I'm going to do one with numbers. Okay, so RT bisects angle QRS, okay? QRS. So I'm going to draw, I don't have it, so I'm going to, oops, sorry about that. I'm going to draw angle QRS. So I draw two rays that meet, they have to meet at R, so I'm going to put the R there, and then I've got a Q and I've got a S. It says RT bisects it. So I'm going to draw a bisector in the middle. I'm going to put a T on it. And then I'm going to make sure that I mark the two angles that it cut congruent to each other, which means equals. All right, so now it says given that QRS is 60 degrees, so the entire angle is 60 degrees. What are the measures of QRT and TRS? If the whole thing's 60 and these both are equal, then I can take 60 and divide it by 2, which is going to give me 30 degrees. If I wanted to use algebra, I could say that these were both x, and I could then say that 2x equals 60 and x equals 30. Okay? All right. One more, last one. Okay, last one, best one. KM bisects angle JKL. So I'm going to first draw JKL, remembering that the K is the vertex, and I'm going to draw the ray inside it, KM. It says it bisects it, so I'm going to mark the two angles congruent. It says the measure of the two congruent angles are 2x plus 7 and 4x minus 41. So now I've got variables in it, but I use the same method. If these both have hash marks, it means that they're equal. So to write an equation, set the expressions equal to each other. So 2x plus 7 equals 4x minus 41. All right, now I solve for x. So I'm going to balance the equations. I'm going to add 41 to both sides, and I'm going to subtract 2x. So that gives me 48 equals 2x, so x equals 24. I go back to the question. The question says find the measures of angle JKM and MKL. JKM and MKL, they're equal, so I just have to find one. I decided to plug my x value into this one because it seemed a little bit easier. The numbers were smaller. And I got 2 times 24, which is 48, plus 7 gives me 56 degrees. So JKM is 56 degrees and MKL is 56 degrees. All right, guys, so that's our lesson on angles. If you need to go back, you can rewatch at any point, and we will finish this up tomorrow. See ya.